Hello everyone, my name is Avindya Beratna and today I'll be presenting on the topic Benchmarks Evaluating Parallelism in Current AI Workloads. In this short video presentation, I'll walk you through what benchmarking means in the context of AI chips, why parallelism is so important, how we can measure it effectively, and finally some real-world applications and recent trends. Let's get started. Before we dive into benchmarking, let's quickly define two key terms. First, benchmarking simply means testing and comparing how well a computer chip performs under specific workloads. Second, parallelism is about doing many operations at the same time instead of one after another. This is especially important in artificial intelligence workload, where training a neural network can involve billions of small calculations. Traditional CPUs process tasks mostly in sequence, while GPUs and AI accelerators are designed to run thousands of operations in parallel. That's why they are the backbone of modern AI systems. So, how do we actually benchmark AI chips for parallelism? The process usually follows four main steps. Step 1 is to select the right workloads, for example, image recognition with convolutional neural networks or large language models like transformers. These are commonly used AI tasks that push hardware to its limits. Step 2 is running the workloads at different scales. This means testing with varying numbers of cores, threads, or belt sizes to see how well the chip handles increasing parallelism. Step 3 is measuring key metrics. We usually look at latency, which is the time taken for one task throughput, which is how many tasks the chip can complete per second and efficiently, which considers energy consumption per operation. Finally, step 4 is comparing results across different hardware, CPUs, GPUs, TPUs, or specialized AI chips to see which performs best in parallel AI workloads. This structured approach gives us a fair and clear picture of how well a chip is optimized for parallelism. Why does benchmarking parallelism actually matter in the real world? Let's take a few examples. In self-driving cars, AI must process camera and sensor data instantly for safe driving. Only highly parallel chips can deliver this kind of real-time performance. For large language models like ChatGPT, training spreads workloads across thousands of GPUs. Benchmarking helps identify which chips handles this scaling most efficiently. In recommendation systems like Netflix or Amazon, AI processes millions of interactions in parallel to suggest content quickly. Finally, benchmarking also guides energy efficiency, helping choose chips that maximize performance without wasting power. In short, benchmarks help select the right hardware for the right AI applications, making AI practical and sustainable. One of the most important recent trends in benchmarking AI chips is MLPerf. MLPerf is an industry standard benchmark that evaluates AI hardware on real world tasks like image recognition, language translation, and recommendation systems. Companies like NVIDIA, Google, and Intel regularly publish MLPerf results to show chip performance. For example, in 2025, NVIDIA's H100 GPU and Google's TPU V5 achieved record MLPerf results, demonstrating not just speed but scaling efficiency and energy performance. This trend is key because it gives researchers, companies, and students a fair way to compare different AI chips on the same benchmarks. To wrap up, here are the key takeaways. Parallelism driven modern AI performance. Without it, large AI workloads wouldn't be feasible. Benchmarks provide a fair way to measure and compare hardware for different AI applications. The approach is simple. Choose workloads, test at scale, measure key metrics, and compare results. MLPerf is helping the industry standardize benchmarks, making AI chip performance transparent, measurable, and fair. Benchmarking parallelism is thus a foundation for advancing AI and higher performance computing. These are the main references I use. They include HPCWire, best practices, MLPerf details, and official documentations for NVIDIA H100 and Google TPU V5. I'll include these links in the video description for further reading. Thank you for watching. I hope this gave you a clear understanding of how benchmarking helps evaluate parallelism in AI workloads.